When talking about functions, one of the things you heard me mention was this idea of parameters, information that we can pass to the function to make some difference in how the function operates. It's data we can pass in. When we talked about our sandwich making function, we talked about passing in ingredients and getting out a sandwich. So let me talk a little bit more about parameters and what that might look like. Let's remember for a second what we were talking about when we were talking about functions. Functions were this contained set of code that we could call and use again and again and again, and how it was used might be dependent on what kind of information we gave it, right? So when we first wrote our function, let me skip out for a second. When we were writing our first functions, we were writing the simple function, say cheese, and all this function really did was print out cheese into the terminal. It did the same thing every time. No matter what context we were calling the function in, it did the same thing every time. And that's in part because it had no parameters. So if we jump back over to our discussion of parameters, let's imagine for a moment we're still talking about our sandwich making function. Now, in the way that we wrote our say cheese function, right, our sandwich making function could be called and it would just make the same sandwich every time, maybe a peanut butter and jelly sandwich. But if we didn't want that, if we wanted a function that could make different kinds of sandwiches, we're going to have to pass it different kinds of ingredients. When I say pass it, what I mean is put into the function information, or in this case, ingredients, like, say, bread, ham, cheese. We would take all of these ingredients and we would put them into our function. Our function then would run its code, right? And when we were talking initially about sort of abstraction, right, sequencing of events, our code might say things like slice the bread, put one ingredient in, put any other ingredients in, close the bread up. Ultimately, then it would return a sandwich, right? Our function would take in these parameters, this data, in this case, ingredients, right? It would take this stuff in, and what it would put out, its output, would be a sandwich. So that's the way I want you thinking about parameters. Parameters are what we're going to hand to our sequence, our steps, our function, and it's going to change what is produced out of our function, what our function does, right? Our function will do the same thing given the same ingredients, but what it does differently is going to depend on what parameters we pass it, what ingredients we pass it. So let's go back to our function file here. And let's imagine we actually want say cheese to do something a little bit different every time we call it. In this case, we want it to say, let's say, greet person named. Okay, greet person named. And we're going to say we want it to be given a name. So that's how we would change our function definition. Notice here, I'm putting the word name. In this case, the word name is standing for the name parameter that we're going to pass in. Inside of our function, so now name sort of becomes this temporary variable. Temporary is maybe not the right word, but I want you to understand that this variable name is only going to exist for the life of one function call, and then it's going to be discarded. And every time we call our function, we're going to remake this variable name with whatever parameter is passed in, and we're going to use it for the life of the function, and then we're going to discard it. Call the function, name gets created with whatever parameter is passed in, discard that variable. Inside the function, we can now use name. So if we're going back to sort of our formatted strings using our F, right, our F strings, we could say hello, and then we would say name. Now you'll notice name and name match, right? The colors match, the italicized match. What it's trying to indicate to us there is this okay, now you are referencing this variable that you have created for this function called name. So now, let me take out the rest of this code for a moment because our function is no longer called say cheese, but now we could say greet person named, open up our parameters list, and you'll notice in our doc string, right, there is now this parameter name, and it will take any. Now, some programming languages are going to require you to say what type of information you're passing into a function. Python doesn't require that of us. It's going to try to work with whatever information we pass in and do its best, right? Which has its drawbacks and benefits. Don't worry about it too much right now, but I just wanted to point out that's what that any means. That any means any data type, right? We can pass in any data type. It might not always work, right? But we can pass in any data type. In this case, we're going to pass in a string. I would like it to greet me, right? So I'm going to say greet Mr. Huber. Let's go ahead down here to the code and let's run our function. And we see hello, Mr. Huber. Now, that's not that different than our say cheese function, right? That looks like it's working the same way. Here's where parameters become powerful. Now, I want it to greet a person named Captain America. Okay. Let's see what happens. Now it says, hello, Mr. Huber, because that's the first time I called the function with the parameter Mr. Huber. The second time I called the function, it was with the parameter Captain America. So it greets the person named Captain America. And this is how functions get a little bit more power, because we can write this logic that we can then apply to any set of parameters to get results that make sense. If we were to think about our calculator program for a second, we could write a separate function called add two numbers, right? Add these two numbers. Maybe not the best name for a function. Certainly not the most robust function, right? I'm sort of limiting it in a lot of ways, but for now, as an example. And we could name our two parameters, num1, num2. Not great names, but it'll work for now. And then we could just have it print out in an F string num1 plus num2. And then we can call this function, add these two numbers, and pass it integers like 1 and 2, 1 and 3. We could pass it integers like 4 and 7. And they don't even have to be integers in this case. It'll actually work with doubles too, I think, if we wanted to. Let's give it a shot. Yeah, so here we have 1 plus 3 is 4. 4 plus 7.4 is 11.4. Right? So we're able to create this function that we can then use again and again and again throughout our program, but it will work with different data that we pass it, whatever parameters we pass it. In this case, num1, num2 are the parameters that we're passing it. We can pass it more than one, as I did in this case, right? We can pass it 2 parameters, 3 parameters, however many we want, as long as we're willing to list them out here if we want individual parameters. You can also pass a list as a parameter. So if you remember our discussion of lists and what we can do with lists, lists is a collection, right? A collection of data. So if we wanted to do that, let's try out passing a list in, and let's make a function that would make sense for passing a list in. So let's do definition sum numbers. We're going to take a list of numbers, and now we just want to print out the sum of those numbers. Now, if we want to pass a list as a parameter, we need to build it as a list. And if you remember, our lists are actually built in square brackets. And here we have the list I'm passing this function is 1, 2, 3, 4, 5. I'm guessing you can probably guess what the sum function here does, right? This is a built-in function like we talked about before. If you're not sure, you can always look at the doc string. In this case, it goes over an iterable list, right? It goes over an iterable list, and it returns the sum of that list, adding them all together. So when I pass it this list, it takes that list, sums it, and prints it out. And that's what our sum numbers function does, right? It takes that list, sums up that list, and then it prints out that sum. In this case, I've passed our function theoretically more than one number, but really only one parameter. That parameter happens to be a collection of numbers. It's kind of nitty-gritty, picky details, but it's important to kind of understand when you're passing multiple things and what the shape, size, characteristics of those things are. In this case, remember, I'm passing one thing, it's a list, but that list is a collection of things. I say that because we're going to get into some areas where you can pass in sort of variable number of things. In this case, the way this function works, we are sort of passing in a variable number of things, right? There's no necessary limit to what our list could be, right? Our list could be of various sizes and get results. You can also have something called a default parameter. So if I wasn't sure that that our user was going to pass anything in particularly, I could pass in the list of 0. Now, if I do this and I run this function, now, it's going to return the same answer. The reason is when I call the function, I do pass in a parameter. That overrides the default value I set for our parameter. But if I didn't pass in that parameter, if I didn't pass in any parameter, I'm not going to get an error. I'm just going to get 0 because I've assigned that default value. Had I not done that, and I tried to call my function without passing in any parameters, I'll do that again here, I'm going to get an error. I'm going to get, hey, this requires at least one positional argument called nums. But with that default, I'm actually able to accomplish two things. I'm able to make sure that my function always has a parameter that it needs. And 2, I'm actually able to make that parameter optional. So there are going to be times when you may want an optional variable when something maybe isn't true. So let's think about an example of when we might want like an optional parameter. So let's say we're making a pizza. And with pizzas, you definitely want a cheese, a sauce. You may also want toppings, but you may not. So we can do toppings as a possible parameter, but then we can also set that parameter default to no toppings. That way, when someone uses our function, right, we can now print this F string that says, okay, made pizza with cheese and sauce and toppings. And actually, we probably shouldn't write and sauce. We'll just write comma sauce. Now, obviously, this is a toy function, right? This isn't. But I want you to see that we can now make pizza in a couple of different ways. When we call this function, we can say, okay, make pizza with mozzarella cheese, marinara. I don't know how to spell these things. Hold on. Is that how you spell marinara? Let's double check. Okay, good. Marinara sauce, and that's it. So that's one pizza we could make. We could also make another pizza. Let's say we're going to use cheddar cheese. That sounds kind of gross, right? We're going to use we'll use mozzarella still. We're going to use Alfredo. And we're going to put in some sausage, right? And We'll just do sausage. That's fine. Okay. Just to show what the function does. Now, both times the function works. Made pizza with mozzarella, marinara, and no toppings. Made pizza with mozzarella, Alfredo, and sausage. No toppings probably doesn't need to be capitalized here, just to make it clearer for our function. But hopefully, generally, you get the idea. Here, I didn't have to write no toppings. The default is no toppings, right? That's the base. So the user of your function in this case, or you if you're using your function, don't have to write no toppings every time you want to make a pizza with no toppings. That's the base assumption. And so we can leave that out and not cause an error. Then when we want a topping, we can add that in without a problem. There's no issue with adding in sausage or meatballs, something like that. And we could do that and still get results that make sense. So that's the benefit to having default, and then therefore with default values to your parameters, you then make optional parameters that don't have to be used. And the key to that is this toppings equals. You're basically taking that temporary variable we talked about, right? That variable that's going to exist when that function is called, and giving it a value right away. If a user passes in a parameter, that value is overridden. If the user doesn't pass in a parameter, then that value stays, and that's it. And we could do that with our other values here too. Maybe the default value for sauce is always going to be marinara, right? Maybe the default value for cheese is always going to be mozzarella, right? Okay. Oh. And we can have these as strings. I want to make sure that we're indicating that, yes, in fact, these are strings. All right. So that's default values and optional parameters. We can also give our parameters specific names if we want to. So we can say which thing we want to be which. So in this case, we could have said sauce, or we could have said, here, let's go up here. Let's say toppings equals marinara. Now I'm telling my function that the specific parameter that I want to be marinara is actually want to be toppings. And sauce, I want to be Alfredo. Weird pizza, but I just want to show you this sort of feature of parameters. So now when I call this, you'll notice here on this line, marinara gets put into the toppings portion and Alfredo gets put into the sauce portion. So normally in Python, when we want to fill in for parameters, we just have to sort of do it in the order that the parameter is defined. Here's where the cheese goes, here's where the sauce goes, here's where the topping goes. If for any reason we want to change that, or if we want to specify kind of, we don't want to worry about order, we just want to say, I want this to be this to be this, we can do that as long as we're willing to sort of name the parameter as we pass it in. This is going to be my toppings. This is going to be my sauce. It's not in the order that it was defined, but that's okay because I'm naming it as I'm passing it in. Okay, so that's another way of doing that, just to sort of clarify. Okay, this is how this is going to work. So we talked a little bit about passing in lists and kind of the idea that you can have multiple parameters there. Another way of doing that is using what are called args. Oops. I just want to make a comment up here. Args and kwargs, which essentially stands for arguments and keyword arguments. And it's basically the way that Python has for passing in a variable number of arguments outside of a list, outside of a collection. So a simple example of that is sort of, let's make this print the stuff. We're going to make this simple function called print the stuff. And we're going to pass it in args. And you'll notice this special character, this unary character at the front here. And that's the kind of the magic character that's going to do it. We don't have to call this args. We could call it anything. It's just common convention in industry with Python to call this args. And all this is saying is we are going to pass in a list of arguments. And then what I'm going to want to do is for arg in args. print arg. So I'm just going to, whatever the arguments are, I'm going to print the stuff out in a list. So now I can call print the stuff. I don't have to pass in a list. I can just pass in as many parameters as I want. I can pass in 5. I can pass in stuff. I can pass in true. Okay. Notice too, these are different types, right? I'm passing in an integer, a string, a Boolean, and then I could do it again, but this time, maybe I pass in just the word, right? What's neat about this is it's going to work no matter what I pass in, no matter how many things I pass in. I'm not passing in a traditional list. I'm just passing in a variable number of arguments. And then I'm using a simple for loop to move through those arguments and print each one out. I could also actually, probably don't even need to do the loop. If I wanted to, so I wasn't printing out a list, but more just a horizontal list, I can just print out args itself. And in this way, I get this 5 stuff true, and then I get word on the next level. And I could do other arguments here too. We could do 65, whatever we wanted, 0.3. Right now we have a double going on, and it still works, right? So that is what we call a using variable arguments or args. And the thing that allows us to do that is this character right here, the star character right there. We can also use something called kwargs, and kwargs are the same thing, except in this case, we're actually going to be able to name the variables, and we do that by using 2 of these characters. And again, it's tradition in Python to still use the keyword kwargs. And now let's go ahead and print. Let's print the type of the kwargs that we're passing. All right, and now when we call this function, so we're going to call this function print the type. And then when we call this function, when you call a kwarg function, you just have to make sure that you're kind of naming the variables you're passing in. And what's nice about this is you can use them on the inside as long as you kind of know how you're going to name them. So for instance, let's call print the type. And we're going to pass it in, and we're going to name the variables as we pass it in. So we might print number equals 5. We might pass in bool equals, or just B. Bool's a reserved keyword. We don't want to use that. Equals false. Month equals July. Now, I'm going to pause for a moment. I just want you to think about what you think is going to happen with this function. Remember, it's taking in this list of keyword arguments, and it's going to print out the type of each argument. So what is that going to look like in the console? All right. If you want to, pause the video and think about it. Otherwise, let's run the function and see what happens. Okay, good. It actually passed back the class dictionary. So it's not returning the type of each thing. It's returning the type of kwargs as a whole, and it's a type dictionary. If we wanted to return the type of each thing, we would probably have to iterate through. So let's say for kwarg in kwargs. Let's try print type. Let's see if this will do it. Yeah, good. Okay. So in each case, it's printing out type string, type string, type string. Interesting. I think what it's printing out actually is the keyword as opposed to the value. So kwarg dot. All right, so let's do this way instead. Let's go ahead and access. So let me stop for a moment and talk about why it said dictionary and what it's talking about. dictionary is a way that we can compare keywords and values together. So when you pass in kwargs, keyword arguments, what you're actually passing in is a collection. And in that collection, it's got two things. It's got the keyword, kind of the name of the variable, and the value for that variable. So in this case, if we wanted to get out the value for that variable, we could say something like print the type of kwargs, and we would write the name of the variable we wanted to print out. In this case, we want to print out the type of the variable number. And with keyword arguments like this, you want to imagine that the keyword is a string. That's why we got this list of class string, class string, class string, because the keyword in all of these instances was a string. But the type of the keyword in all these instances was a string. But the type of the value is not a string. And that's what we're going to find out here. And we're going to get that by passing in the name of the keyword and getting the value out. And let's do the last one. And this is how you can access all of those keyword arguments inside your function. So kwargs works best when you kind of know ahead of time what may or may not be being passed in your keyword arguments and working with each type as they're passed in. So now if we call it, we get out a class integer, which is true for the first one, boolean, which is true for the second one, and string, which is true for the third one. Notice in this case, because we're not just iterating through and looking at the kwarg, right, the keyword argument itself, where it's saying, okay, the keyword is a string, we're actually looking at the value, not the keyword, but the value, and the value in this case is an integer, a bool, and then lastly, a string. So that's how kwargs work. And we could pass in as many of these as we want, as long as we're willing here to kind of go through and access each one of them. We can do this in a loop, right? There are ways we can work with a dictionary that we can look at each value of a dictionary, both its keyword and its value. But generally, when you're working with kwargs, you're going to be working with specific values that you know or can expect to be passed in. Otherwise, you'll probably just be working with args, because the keywords aren't going to be important to you at that point. You know you're just getting a variable number of parameters, and you want to access those parameters. Okay, that's a lot of information about parameters, but I'm hoping that you can sort of understand, contextualize the fact that at the end of the day, what we're really doing is we're taking our function, right? We're passing in our ingredients, and then we're asking it to make an output based on those ingredients, okay?